To the ancients, the universe was full of mystery, and they had different models to explain how it all worked. The Egyptians believed the earth was flat. Mountains rose from its four corners and supported the sky. Years later, the Greeks started to question these ideas when they noticed ships disappearing off the horizon. If the earth was flat, where did they go, and why did they come back? As people continued to gaze up at the stars, they noticed that during an eclipse the earth threw a round shadow over the moon. From this they decided the earth must actually be round, not flat. "500 years ago, a ship completed a trip around the earth and proved it was in fact a sphere. Since then, armed with powerful telescopes and satellites, we've explored beyond the Earth and found we're surrounded by other spheres. These discoveries have shown us how life on Earth works through cycles and seasons. Everything has a shadow. No matter where you go, you can't get away from your shadow. See what happens to your shadow when you jump. In the early morning, Patrick traces Amy's shadow. At lunchtime, her shadow has moved, even though she's in the same spot. Shadows change like this because of the position of the Earth and Sun. During the day, the sun rises at dawn, moves through the sky, and then sets, and it becomes night. In summer, the sun moves high in the sky. In winter, it's lower. While it looks like the sun is moving around the Earth, it's actually us that's moving. Once a day, the Earth rotates around its axis. We call the ends of the axis the North and South poles. The Earth also rotates on an angle. The Sun is a huge ball of gas, 1 million times the size of the Earth. So strong are the rays of light and heat that the sun gives off that they reach us 150 million kilometers away. Because the Earth is a sphere, this only hits half the planet at a time. But watch what happens as the Earth spins round its axis. If you were standing here, you'd be in day, then night, and day again. We divide the Earth's rotation into 24 hours, about half in day and half in night. But at the same time, one part of the world is in day and the other in night. Because of this, we divide the Earth into time zones. This is the international dateline, which marks where one day starts and the other ends. From here, different time zones are marked by lines about an hour apart. These kids are measuring the passing of time by making a sundial. The flagpole's their centerpiece, and where its shadow crosses the sundial's border, James marks the time. An hour later, the shadow has moved. And keeps on moving through the day. 24 hours later, the shadow will be right back to where it started. Galileo was an Italian astronomer living in the 15th century. He was the first person to look through a telescope and see the moon. Until then, people thought the moon was perfectly smooth. Galileo saw that it was actually covered in mountains and craters. Galileo made many other discoveries, but they got him into serious trouble. What he said was different to the teachings of the church at the time, so he was punished and put under house arrest. Years later, we discovered that Galileo was right about many things.
Looks like we're going to be able to make it, John.
In 1969, Neil Armstrong and Bud Aldrin spent a whole day exploring the craters of the moon.
In the near field on this rim that has some white on the top of it, we'd like you to pick it
The
up.
footprints they left behind will last forever. Because there's no wind on the moon, they'll never blow away.
That is the most beautiful sight. There comes the shadow.
From the moon, you can look out into space and see the Earth. The moon orbits the Earth in a journey that takes around 29 days or a month. The same face always faces Earth. We see the moon because light from the sun is reflected off its surface. Because it's a sphere, the moon is always half lit and half in shadow. Have you ever noticed that the moon looks different every night? While it looks like the moon is changing shape, it's actually just changing position. These changes are called the phases of the moon. We've set this model up to show how this happens. When the moon is here, we only see a small part of the lit side, and this is called the new moon. As the moon moves, we see more of it. This is a crescent. Now it's a half moon. Then three-quarter moon. And when the lit half is fully exposed, we have a full moon. The moon is continually moving through its phases as it completes its orbit around the Earth. When the Earth, Moon and Sun are lined up like this, the Moon blocks the Sun from view and we get a solar eclipse. When they're like this, the Earth throws a shadow over the Moon and we get a lunar eclipse. Every year we have 4 main seasons: summer, autumn, winter, and spring. Seasons are caused by the Earth's tilt and movement. While the Earth does a daily rotation, it also revolves around the Sun. One complete revolution takes 365 days or a year. The equator is an imaginary line around the middle of the Earth that separates the northern and southern hemispheres. In December, the southern hemisphere is closest to the Sun. More sunlight means it's summer down here and winter in the north. So while kids in Australia are hanging out on the beach, kids in Canada and the UK play with snow and ice. With more sunlight, days are longer. On the 21st of December, the southern hemisphere has its longest day and shortest night. This is called the solstice. In March, the sun's rays shine down directly on the equator. On the 21st, day and night length are equal around the world, and we call this the equinox. In June, the northern hemisphere is closest to the Sun, so now it's summer up here and winter in the south. On the 21st of June, there's another solstice with the longest day in the north. And on the 21st of September, the sun shines directly on the equator again and we get another equinox. But not everywhere has 4 seasons. Unlike the poles, the equator is always hit with direct sunlight, so it's always hot. You only get 2 real seasons here, hot and wet and hot and dry. As you move away from the equator, it gets colder. The poles are always cold. During summer, the poles are always in sunlight, so the sun never sets. During winter, they're always in dark, so the sun never rises. When you jump, you land back down on Earth. This is due to gravity. In this spacecraft, the astronauts can't feel gravity, and life is pretty different. If we didn't have gravity, this skier would fly off into space. Because we do, he doesn't. Gravity works by pulling everything towards the center of the Earth. This is why we can live on a sphere. Gravity stops us from falling off. The Moon and Sun also have gravitational forces. These forces try to pull elements on Earth towards them, and this has a big impact on the oceans. Around jetties, water rises and falls during the day. In bays and beaches, water is sometimes high up on the sand. Later in the day, it's much lower. These differences are called tides. They're caused by water responding to the gravitational pull of the Sun and Moon. The pull from the Sun and Moon make the water bulge out from the Earth. This gives us high tides and low tides. During the Earth's daily rotation, we move through high tide, then low tide, high tide again, and low tide again. So every day we have 2 high tides and 2 low tides. Tide times are recorded in tables which people use to find out the best time to go out fishing or surfing. When the Moon and Sun pull in the same direction, we get big high tides and very low low tides. These are called spring tides. When the Moon and Sun pull in different directions, we get smaller or neap tides. Life would be pretty different if we didn't live on a sphere. Imagine a cubed Earth. Or cone. What if the Sun was a prism? Life on a spherical world is pretty complex, but there are 3 main things you should remember. Once a day, the Earth rotates around its axis. Once a month, the Moon orbits the Earth. And once a year, the Earth revolves around the Sun.